Adriano Siqueira. I am from University of São Paulo at São Carlos. And this work was done by my master student, Felipe. And the idea here is to evaluate control strategies for telerehabilitation. So to do that, we have designed a robotic platform and used a game designed with Unity game engine. So regarding robotic rehabilitation, I have already said in this conference, so we have, with robots, we can perform some specific and controlled tasks to the patient. We can also increase the productivity and efficiency of the therapy. And also we can evaluate the patient progress during the therapy section or during the all therapy. And specifically for robotic telerehabilitation, the idea is that the data from the robot and the game is transmitted over internet. And in the telerehabilitation for robotics, and we can do this in two classes. One is the unilateral, where we have only one robot, and the patient is playing some game. And the data is transmitted to a therapist that is in a remote position. And the therapist can change the parameters of the game or the parameters of the control system of the robot. Another class is with a bilateral class, where you have two or more robots playing. And the idea is that the two patients play the same game. In this example, we have a football game we have developed, and one player is one patient is one player, and another patient is another player. Okay. In this kind of class, we can design two kinds of games. One is the interactive game, where you don't have direct force feedback between the two players, and you can also have a cooperative game where the two players, for example, in this paper in 2004, we have a beam, and the two players have to move this beam around the scenario. So to do that, we have to use some strategies from robotic teleoperation. And to study these control strategies for teleoperation, we have designed this platform, this robot platform. It's a very simple platform with two motors and two handles. And associated with this platform, we have this game designed in Unity 3D, and one handle of the real platform is associated with one handle of this virtual platform. Okay, and then the idea here is to balance the ball in the beam, so you can move the ball to right or to left. And the communication between the real platform and the virtual platform is made through TCP/IP sockets and using the JSON format and in a network. Okay, so the control here you have a move. It's not so good, but you can see in the bottom left the real platform. When you move one handle, another handle also moves, following the motion of the the virtual platform. It's not so, okay. And the idea here is to guarantee the instability of the motion of both motors. So we have evaluated three kinds of control strategies for teleoperation, robotic teleoperation. The first one is the PD's symmetrical control. The second one is using wave variables. And the third one is using the virtual dynamic model given by the unit 3D. So the first one is that symmetric PD control. You take the position and velocity of one motor and define then as desired position and velocity to the other motor. And you take the position and velocity of the slave. Here you have teleoperation, you have the master and the slave robot. You take the position and velocity of the slave and define them as desired position and velocity to the master robot. And here you have some results. In the left is the motor 1, the right motor 2. And first I move the motor 1 and the motor 2. The desired position to motor 2 is defined as the position of motor 1. And the motor 2 follows the first one. In this part of the graph is when I move the two handles in opposite side. So in this case, the force, this is the torques. These are the torques in the motors. So the torques in the motors are equal each other. So you can transfer the force one patient is doing to another patient. Okay. The problem is that when you use these control strategies for higher delay in the internet, you have some instability. Okay. So you have to use another kind of strategy, and one is using wave variables. Basically, you get the velocity and torque of the one motor and combine them as one variable. It's a wave variable, and transmit this variable. As mechanical engineers knows, velocity and force, you have power. So you are transmitting power to the other motor. Okay. So this guarantees stability of the for the system, even with here's the same with low delay, and for a higher delay, you can guarantee stability of the system with this kind of control strategy. The last strategy is using the all dynamic model given by the unit 3D. So we get the torque generated by both motors and combine them and apply to the dynamic model of the beam in the virtual platform. And as a result, we have the position and velocity of the platform, and these values are transmitted to the motors as desired position. So with this strategy, we show that we can guarantee stability of the system. Basically, it's working very well also for high delay. Here are some examples of the motions. And so we have shown here initial study about the robotic telerehabilitation with force feedback between two patients. And the idea is to study future works. If we use social games with 2 or more players, we can have a better result only when we use only 1 player. And also, we are studying adaptation algorithms for interactive and cooperative robotic telerehabilitation. In the case we have 2 patients, 1 patient is in a better condition than the other patient, so we have to equalize the difficulty of the game so that the lower condition patient is still motivated to play. Okay? Thank you very much.